student, and welcome. This is a mathematics session, and specifically I'm going to take you through two topics that are very much related. Angle properties of a circle. This one is covered in form 2, and circles, especially chords and tangents. This one is in form 3. Okay, after taking you through the properties, I will take you through 5 questions or 5 examples. Like this is question 1, question 2, question 3, 4, and 5 there. Both of these topics are talking about a circle. So if I have a circle, this one is the circumference. The boundary is basically the circumference. So if I have a line starting from a point A to another point B on the circumference, that line is called a chord. That one is called a chord. The distance from here along the circumference to this one, it is called an arc. So this is the minor arc, and of course we have the major arc. If I have this area, so this one, it's called minor segment, and this of course major segment. A distance from the circumference, a point on the circumference to the center, it's basically the radius. If it continues, if you have a straight line, maybe to a point C, so the line BC is simply then the diameter. If I have a line joining the center, the chord AB, when you start from A to the center, B to the center, an angle is formed. So basically what we say, that the chord AB has subtended. Yeah, there is a word I will use very many times, subtend. So it has subtended an angle theta at the center. It can as well subtend an angle. It can form an angle at the circumference. So maybe alpha. If I have a chord that extends, like if I have a chord that extends, basically that is called a secant. A number of things you need to know about the circle, but those are not of interest at this for this session. Now, these two topics are very important because mainly in paper 1, section 2, the long structured question, you can have a question from these two topics, yes, carrying 10 good marks. So what exactly am I going to do? I'm going to take you through 10 properties. Then we get 5 questions, 5 long structured questions, and we go through them together. And we start with the first 3 properties. Property number 1, angle subtended by a chord at the circumference. Okay, assume that I have a chord here, a chord AB. Okay, so if I extend this like that, so the chord AB has subtended an angle ACB. If this one is theta, and it happens that this chord subtends another angle on the same segment, theta. So these angles are equal. Even if I have another chord, I can have another chord PQ. If PQ is equal to AB, this chord PQ can subtend maybe an angle beta. The angle beta and theta here, they are the same. What exactly can we say about these two properties? If I have a chord, it is subtend equal angles on the same segment. That is property number 1. If I have a chord PQ and a chord AB, yes, these two chords are equal. So even the angles, they are going to subtend on the major segment, like for this case, they will be equal. So those are 2 properties. If I have this angle subtended at the center and angle subtended at the circumference, assuming that that is the center of the circle, and I have a chord here, maybe it's XY. Now, the chord XY can subtend an angle at the center. It can as well subtend another angle at the circumference. So I have an angle here and I have an angle here. So what is the connection between these two angles? For my student, you should know, if this is theta, this is 2 theta. That's a property you should master and get it. That the angle subtended at the circumference is always half the angle subtended at the center, or the other way around. And very fast, we go through another 4 properties here. One, it is the angle subtended by the diameter. So I'm assuming that AB is the diameter. If I have an angle subtended by the diameter to the circumference, that angle is always 90 degrees. That is always 90 degrees. So any angle that is subtended by the diameter at the circumference is always 90 degrees. Assuming that I have a circle, I have a figure here, like that one. I have a figure A, W, X, Y, and Z. These two angles, the opposite angles, like I can have these two, alpha and theta here. The alpha and theta, if added, I will get 180. A very important property you should know. If I have this one, maybe it's beta, and this one maybe is gamma. So beta plus that gamma there, it will give you 180. So the opposite angles of a cyclic quadrilateral add up to 180. Property number 6. The angle between the radius and a tangent. Remember, what is a tangent? It is just a line touching a point on the circumference. So like this is a tangent. So if I have the center there, this is my center, so, and that is the radius. A property number 6 that you should know. The angle between the radius and the tangent of a circle at the point of contact is always 90 degrees. Think about this one. I'm now giving you another property here. Assuming that this point of contact is point T, and I have maybe point S. So I have a chord that starts from T to S. And this chord can subtend an angle at the circumference on the opposite arm of the alternate segment. So what exactly should you know? The angle between the tangent and the chord here, yes, is always equal to the angle subtended by that chord on the alternate segment. Maybe when you're given a question, it will be so much mixed up of several properties, but that one you should be able to isolate it just the way it is. The angle between the tangent and the chord, theta, it is equal to the angle subtended by the same chord on the alternate segment. Maybe the next one here, for instance, assume I have a tangent at a point A, and I have another tangent here at a point B. And of course, I have the center of the circle, the center of the circle. Now, if I have this, okay, and I have that one, I want to see the connection between this angle and this angle, okay? Actually, if I have this as angle theta and this one as angle beta, if I take beta and I add that beta, I will get 180. For instance, if I can join this one, okay, if I join this one is 90 degrees, okay, and this one is 90 degrees. So whatever the angle is here, yeah, if I have this angle and this is y, automatically this will be y and this will be x, okay? These two, x and y, add up to 90. X and y add up to 90. That tells you the angle AOB and angle ATB add up to 180. That is, they're supplementary. I have another property here. Assume that I have a chord. Then I bisect the chord. Automatically, we usually say the bisector will always pass through the center. Remember, this is a perpendicular bisector. And that bisector bisects any other chord that is parallel to this one. Hit another chord maybe here, provided it is parallel to the first one. So this one, it's divided into 2. This one divided by 2. This one divided by 2. Before we go to some questions, I want just to remind you this. The angle sums of a triangle. If I have a triangle, A added to B added to C will give you 180. A property that you need to bear in mind. If I have a straight line, again A plus B plus C equals to 180. Angle sums of a triangle, angles on a straight line. They are supplementary. Why do I teach you this? Because we truly need them when we'll be doing the long structure questions for a mathematics paper. Now let's go to the first question. Let us look at the first example here. You're given this question, a 10 marks question in section 2. You're given the figures. You can see there is a line RSU, a straight line, QTU, another straight line. So these are the angles that you're supposed to work out. Let's start with the first one. We find the angle RST, 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 this angle here. Remember, it's not just a matter of giving out the angle. Give the angle and support your answer. Let's look at that angle keenly. There is an angle RST. And if I can consider QRST is a cyclic quadrilateral. And this one I'm given. So automatically this angle will be 180 subtract 46. I get 46. Then I get 134 degrees. The reason for that, opposite angles of a cyclic quadrilateral add up to 180. So already that one we have 2 good marks. So we have this 134 degrees there. Then we go to the next. SUT. Yes, we find this angle. We find that angle. Now, here you need to think deeply and widely how to get this angle. You try as much as possible to connect the property that will give you third. Remember, QT is the diameter. It is passing through the center. So automatically this angle is 90 degrees. So with that, I can consider the triangle QRU. And therefore, I have the whole of this. I have this. I only have the third angle missing here. So the angle at Q, at R, and at U when added, I get 180. So to get this, I can do 180, subtract the sum of these other three. 90 plus 37 plus 46. If you can use your calculator to work out that, you'll get that this angle is 7 degrees. A very small angle there, but I have it. What exactly have I used? Angle sums of a triangle. Then I get the angle ROT. ROT. Yes, I'm working out that angle. Let's think about the chord RT. It is subtending an angle at the circumference here. The same RT is subtending the angle in question. So one of the properties that we studied, that angle subtended at the center is always twice angles at the circumference. So for that one, it is 46 times 2, 92 degrees. The reason for that, the center is always twice the angle of the circumference. So we have this is 92 degrees. We go on, PST, that angle, PST. That one is an angle that is subtended or that is made by PQ. So the chord PQ has also subtended an angle here, this one. Remember this one, the whole of this angle QPT is 90. So if that is 90, yes, it means this is 48, automatically this is 42, the complementary of 48. So with that, even the angle in question here, it is the same, 42. The angle subtended by the same chord, 42. So this one is 42. There is an angle subtended by the same chord. Then we have the very fine one, the reflex angle SOP. The reflex angle, reflex more than 180. So what exactly do I do with that? If I consider the chord PT, PT subtends an angle of 42 here. With that, the angle at the center, it will subtend at the center is 84 degrees. So already I have angle TOP. Then I have the chord ST that subtends an angle of 37 at the circumference. So automatically the angle here, it is twice the 37. So it will be 74 degrees. So I have this obtuse angle there. It will be 74, you add 84, get 158 degrees. So if I have the 158 degrees, I can easily get the reflex angle. It will be 360 subtract 158 degrees, and if I do that, I get 202 degrees. Actually, if it is an exam, showing your working is very important because it will support your answer. And that's how I get the 10 marks from this question, the first example I'm giving here. This is another question, a long structured question on angle properties of a circle, and also involve tangents and chords there. Now, actually, for this one, I may prefer we go attack the question first, then we go to the specific questions they are giving us. Remember that you're told that DA is a tangent to that circle at D. BA, it's a tangent again. Yep. You're also told that DEF is a straight line. Of course, you can see the rest of the chords there and the way the diagram is. Remember, these figures are not usually drawn to scale. So do not say this angle looks like 90, it's 90. No. Now, I can start by attacking the question here. If this is a tangent and this is a chord, this angle is 42. It means the angle subtended by this chord over here is also 42. If this is 42, this is 48, that makes 90. And that tells you this angle here, this one, it must be 90 as well. And that means even the internal angle here, this is 90 as well. Now, the chord DE subtends 42 here. So the same chord DE subtends an angle here 42 degrees. So if I can have a center, this may be center O. Okay, remember what we said, this angle with relation with this one. These two angles will add up to 180. So if this is 48, the whole of this angle here, 132 degrees. So if I know the angle DOB, 132 degrees, so automatically I know this angle. That angle will be half of this. Yes, 66 degrees. Now we can work out this angle alone. 66 minus 42, I'll get 24 degrees. So if that angle is 24 degrees, ECB, that means it is the angle subtended by the chord EB. And therefore this angle here, the whole of that is also 24 degrees. We can go to the question and see what exactly does the examiner needs us to do. The angle DCE. The angle was not there before, but we have related it to this one, 42 degrees. The reason for that, angles subtended in the alternate segment by this chord. Remember, these are chord and these are tangent. So we have that. Then the other one is angle BCE. BCE. That one we have been able to relate several things here. We have been able to get the angle at the center. Yes, angle at the center, 132. Yep. Then a half of it. We have related this. A half of it, 66. Then you do the subtraction. And then you get the angle BCE being 24 degrees. Then DCB. DCB, the whole of that angle. You can just say it is a half of 132, or 42 plus 24. And this one is 66 degrees. So you can do angles at the center is half the angle at the circumference. Then DEB. DEB. Yup, that angle. That one we had not worked it out, but we can work it out now. The whole of this angle, look at this, CDEB, a cyclic quadrilateral. So with that, if this is this is 66, automatically that is 180 minus 66, and you get the answer for that, 114 degrees. 114. So this is 114 degrees. Angle BEF. 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 Okay, the angle down there. That can be complementary of 24. 90 minus 24, you get 66. All of it can be angles on a straight line. If this is 114, so the supplementary angle there will be 180 minus 114. You get 66. Good. That's how you do the question number 2. Question 3 here. You're given this diagram. The diameter AOD. Another very parallel chord to the diameter B, MC. Then you have a point E, and there is a tangent at point E extended somewhere to point F. Then there is a line FO, a very straight line there. So you're supposed to find the angle COE, that angle. How do I go about that? The arc EC has subtended an angle EBC here. It has also subtended the angle in question at the center. The angle at the circumference is always half the angle at the center. So automatically this angle is 40, twice this one. The angle at the circumference, 20. The angle at the center automatically will be 40. So we are done with that. We go to BEC. BEC, the whole of that angle, the whole of that angle. Now, how do we go about this? How do we go about this angle? There are several ways we can do. I assume the chord BC has subtended an angle down here, this angle. And remember, this chord is equal to this, so they are equal chords. So automatically they will subtend equal angles. So even this one is 40 degrees. I know the angle subtended by chord BC at the center is 80. So automatically this will be half of it. So this will be 40. So if I'm looking for the angle, I will consider this. If maybe I have this point, I will consider BXCE as a cyclic quadrilateral. And if this is 40, the angle they're asking about is 180 minus 40, which is 140. Remember, it's the same as what we could have said. This is 70 and this is 70, because this is a 90 degrees here. So it could have been the same, 140. But whichever the way you use, provided you support your answer. BEF. BEF. Yes, this angle here. As simple as I've done, this one, the angle here is 90. Yes, that's 90. Already we know the inside is 70. So 70, 90 minus 70. The angle we're looking for here is 20. OMB. OMB. Well, that is 90 degrees. That's one of the property we say, that a line passing through the center, yes, will always be a bisector, a perpendicular bisector of any chord, like it is there. So this is 90 degrees. So that one we have no issue, it's a right angle. Or FE, that angle there. So remember, this one was a bisector of the angle here. So these two angles are equal. If they are equal, remember the 90 subtract 40, that is 50. Divided by 2, 25, 25. Yes, remember that angle here is 90. You can talk of this FEO being a right angled triangle. And therefore this is 90, so this will be the complementary of this sum. Remember the sum here will be, you add 40, you get 65. So the complementary of that, minus 65, you get 25. So this one is 25 degrees. And with that, you have been able to get to the 10 marks very easily. And I know maybe for most of the students, explaining is the problem. But once you have the angle, already you have the first mark. So now explaining. So get the 5 marks first, then explain. For question number 4, another very good example here. You're given the figure as you can see. Yes, this is the center of the circle. There is a secant here. There is an angle of 60, and the radius is 6 centimeters. Now, you're supposed to find angle ABC. ABC. Maybe first of all we get this angle, the angle CDA. As you work out that, you write it down. The angle CDA is 180 minus 60. Angles on a straight line. So that is 120. So this angle is 120 degrees there. If that is 120 degrees, automatically BCDE A is a cyclic quadrilateral. So automatically this one will be 180 minus 120. So this will be 60. So the angle they are looking for, but A Roman 1 is 60 degrees. The reason for that, the opposite angles of a cyclic quadrilateral, angle CAO. So we're looking for this angle here. We can work out the angle COA, which will be twice this. Angle at the center is twice angle at the circumference. So which will be 60 times 2, it will be 120. Yes, you need to work out on that space. So this one is 120. If that is the case, this is the radius, this is the radius. So COA and isosceles triangles, the base angles are equal. So the way to find the base angle will be 180 subtract 120 divided by 2. And that is how you get this angle, 30 degrees. Angle ACD, yup, this one. And you're given that CAD, this one is 20. So again, this is a triangle with the 120, 20, and unknown there. So the way to get the unknown, it will be 180, subtract the sum of the two. Yes, subtract the sum. And that will be 180 minus 140. You get 40. So the angle here they're looking for is 40. And of course, you can show you're working very, very well. The last part, part B, you're supposed, remember this is 2 marks, 2 marks, 2 marks, 4 marks here. Yes, you're supposed to work out the area of the major segment ABC. So if I have this one, so this one, the whole of this one, so this is the boundary here. You find the area, this one. So what exactly do you need to do? You do the area, okay? You do the area of sector, then the area of the triangle. And I can start with the area of the triangle. It will be this one now. Area will be given by a half, 6 times 6. Yes, 6 times 6. Then sine 120. Sine 120. If you can key in with your calculator that one, yes, because I've worked it here for myself, it will be 15.588 cubic centimeters. Then I work out the area of the sector. Yes, so it will be 360 subtract 120. You get 240. So the area there will be 240 over 360 times, remember it is pi over, that is theta over 360 times pi 142 times radius. Yup. Working out that with the calculator gets 75.408. Now it's a matter of adding the two. 15.588, you add 75.408. And if I'm to add that, I'll get 90.996 centimeters squared. And that one, you're able to get the other 4 marks there. Example number 5, and this was in KCSE 2021 paper 2 number 19. This was question number 19. And remember, this was 3 marks, 3 marks, and of course this was 2, 2. I think 2, 2. And that means if the student was able to get the first 2 angles, Well and good, 6 marks out of 10. Now, the figure is as I have given here, a bit detailed here, but the student could have been able to handle this. The first part, A Roman 1, we find the angle AEC. AEC, the whole of this angle. We can start just at random working out what we know. This angle is given, it's 30. This is a tangent. The angle between this chord and the tangent. Automatically, it is the same as this angle. Angle in the alternate segment. If we consider E, B, C, D. Yes, D. If I consider that, that is a cyclic quadrilateral. So that means I can tell this. The opposite angles of a cyclic quadrilateral add up to 180, so this one will be 70 degrees. Having done that, I have the angle ABC, 100. The whole of this angle, 100. So for me to get this angle, it will simply be 180 subtract 100. I will end up with 80. So the angle I'm looking for is 80. The first 3 marks, just like that. Get the alternate angle to this one, or angle in the alternate segment. Get the opposite angle of this 110 in the cyclic quadrilateral. Then get the opposite of this cyclic quadrilateral ABCE. And then get 80. Very easily you get 3 marks. Then angle AEB, the whole of this angle here. If I can consider this, like I can join this one, this was given to be 55, this is the radius, this is the radius. So BOC, whichever, it's an isosceles triangle. So the whole of this angle here, this one alone is 55 degrees. 55 and 55, 110. From 180, you get 70. Remember that one you can do by writing. No big issue. Just write it down. Write it down. 180 minus 55 times 2 there. You get, subtract there, you get the 70. Having done that, I can get this angle. How do I get this angle? Called BC subtend 70 at the center. It will subtend half the 70 at the circumference, this angle. So this is 70 over 2, 35 degrees. So this alone, 35 degrees. So it's possible to work out this. It will be 80 subtract 35. You get 45. So the angle I'm looking for here is 45. By doing that, as simple as I've done, though for a student you require to think and think and think again, I have gotten 6 good marks. Now, you are given that AB is 5 centimeters. You're also given that ED is 4.4 centimeters. Then FE is 2.5 centimeters. The question is work out the radius of that circle. If I look at the triangle EAB, the 3 vertices are all along the lines of the circumference. So with that, I can therefore apply what we call the sine rule. The sine rule states that, like, I have this angle, I have this side. It says that if I have like that side 5 divided by sine of the opposite angle there 45 degrees will be equals to 2 radius, or whichever other sides you're given and the angle. If the student is able to work out this, divide by 2, then your R will be 5 over 2 sine 45. The student was able to get 3.5 centimeters. So, and that is now B Roman 1 done. With that, I can now do part 2. That is working out AF. AF. This is the line in question here. Good. With that, I can erase here, and that means I need a bigger board here. I think I'll be attaching my M-Pesa number there, so that you student and your parent there facilitate the purchase of better equipment and even bigger board here. But we are working out AF. Look at this. This is a tangent at point A. So we are looking for AF. And then there is a secant here, starting from F to D. So how do we go about that? Though I will explain later what I'm doing. AF squared, it is given by DF multiplied by EF. I will explain later what exactly I'm doing there. Now, what is DF? 2.5 plus 4.4. You get 6.9. So 6.9 times the outer one, 2.5. If you work out this, you get 17.45. Yeah, 25, I think. You can confirm with your calculator. So if I'm working out AF, will be the square root of this one to one decimal place, 4.2 centimeters. 4.2 centimeters. Now, basically that is how you go about it. But I want to show you something, how I have related the very last part here. And that's what I'm doing briefly as I wind up. The concept that I want to explain here is very important. Actually, it is related with circles, chords, and tangents and all that. And it's very important so that you are able to relate. Like this is a secant extended to point C. Another secant extended to point C. Now, if I have that chord and I have another chord starting from here, I can relate something here. I have two triangles here. I have a triangle that looks like this. Allow me extract this. This is point D. I'm talking about this triangle ADC, but I've overturned it. So with that, this point D, this point A, this point C. And I also have another triangle EDC. I can draw it here again. Let's look at these angles. Angle C here of this triangle, it's here. It is the same here. So that these two angles are CC, they are equal. Now we have a chord here, an imaginary chord that subtends an angle BAD here. That one. It also subtends another one here. So these two angles are equal. The angle at A, yes, and the angle at E, they are equal. What does that mean? If these two angles corresponding here, they are equal, automatically this angle, the third one, is equal to this. What does that mean? The two triangles are similar. So we can relate. We can state that DC divided by BC must be equal to, I can say AD over the corresponding here EB, which is equal to AC over EC. Now I can try to relate what I've done here. DC, I can first of all ignore this one. DC times EC equals to BC multiplied by AC. If I have a secant, the part that is outside DC, here it is, multiplied by the whole secant, yes, up to here, EC, is equal to the whole of this, that is AC multiplied by BC. I hope you are able to see what exactly I've done, because when you're given this question, it will simply be from here to the end of that secant multiplied by this up to this, okay, then equals to the whole of this one multiplied by what is outside. So in case you're given, like they have given, this is 4, this is 5, x, and this is 3, it is possible to work out x. It will be x plus 3 multiplied by x equals to 9 multiplied by 5. Similarly, if I have, like for this one, without much of ado, if I have DC, remember now it is like this one, only that now it is cutting here. So it is repeating itself. So DC times DC will be given by AC multiplied by BC. Basically that, as simple as that. To get the formula, get it well. If I have a tangent, so the tangent is solved to the point of intersection squared, equals to the whole secant multiplied by the outer part of the secant there. And that is it. Otherwise, thank you so much, my student. I know this has been maybe very helpful to you. Thank you. Be coming back for more and more. Section 2, it's a very important section for you. You have 5 questions to do. So if you are able to do 5 questions, and then in each question you may score a minimum of 7 marks, that is 35 already. So you need like maybe 20, 30 in the section A, and of course you score a good grade. Otherwise, thank you and continue practicing mathematics. This is Dr. Sirme.